So this technology is also available, and you can see very clearly CAGR is 18.1%. So very soon we are going to do EOI for this technology also. For gallium nitride technology, EOI is already out. Yesterday I met 2 contenders, and if anybody else is interested, they can also come forward. Next. Working on other wavelengths, but the technology of fabrication remains the same. So if these, if you want to get laser diodes, you can approach GATEC Hyderabad. They can fabricate in a single wafer. You can get around 600 to 700 laser diodes, depending on the power you want. So if you want only the laser diodes, you can apply. You can ask for laser diodes, and if you want to absorb the technology of fabricating laser diodes, that is also there with us, and that is also open for absorption. And this can be used for you can use it in quantum application, quantum technology. SWIR, LWIR, and MWIR. In MWIR, starting from the material, our technology is based on MCT, mercury cadmium telluride. Starting from the material, going up to the camera, everything is being done by us. The cryocooler, the DIVAR, everything is available, and it can be used. And can you play this video? This is the output of our camera only, and you can see the CAGR for this is 20%. So this technology can be taken up, can be utilized. It has got a huge potential, and it can be supported by SSPA. Next technology is SWIR. In SWIR also we have 640 by 512. Right now we are doing 25 and 15 micron format, and the whole technology is available with us. We are fabricating it at GATEC Hyderabad, and hybridizing it at Star C Bangalore. If somebody wants to have the technology, this technology is available. And this is just to show the comparison of the imported sensor with our sensor, and you can see the CAGR for this technology is also very, very high. It is going to grow, as Madam said, we are going from man to unmanned. So the kind of sensors which are required for the situational awareness, I think everybody is using SWIR and MWIR for situational awareness, and these are the technologies which can be used. Similarly, we are into LWIR technology also, and if such things are required, We are open for giving the technology, and if you do not want to absorb the technology right now, you only want to build systems, we can provide you with indigenous solutions. As Madam had rightly put forward, that looking at the geopolitical situation, if you do not have your sensors, then you are nowhere. At the point of war, they may deny you these sensors. Then the whole thing can get stuck. So it is better to have the indigenous sensors. So you can start with getting indigenous sensors, and later on, if you want to absorb the technologies are also available. Next. Then we are into, as I said, a number of sensors are being fabricated and tested. We are into inertial navigation, pressure sensors, and all sorts of sensors are available. These sensors have been designed, can be designed, have been designed, and if you want anything which is not falling into this, that also can be done. We have the bandwidth and the capabilities to do it, and all these can be fabricated at Starcy Bangalore. Starcy Bangalore is the next. Starcy Bangalore is our partner where we can fabricate all these things. You want to have in numbers, you can have in numbers. If you want to have the technology, you can have the technology, and we can support you with the cryo cooler technology also. We have JT cooler. Madam is coming. It is a successful TDF project given to us by her, and it is the project for which, Lindred had approached our DG during Aero Show, and they want to have this product in their chain. And if they absorb that project, it will become the part of their global chain. So that way, if they can believe us, I'll ask my industry also to be believers. And similarly, we have the Sterling cooler also. In Sterling cooler, we have two options, 500 and 300 milliwatt. Both options are available. And we have done MOU to Army. We have given these systems to BSF, and they are very happy with it. And in fact, they were saying that they have repaired around 100 units per month they are repairing. So you can imagine the amount of cost which Government of India is saving by using such kind of solution. Next. So as I said, from Starcy, you can have a number of solutions. And if those solutions are not written here and you want something specific, we can take it up as a project, and within a year, we can come out with solutions for that. In addition to all this, we are also into advanced materials. We have certain technologies for which we have already done EOI, like germanium, next germanium blank technology. This was done, in fact, about 10 years back, but at that time, China was offering at very low price. So here I would like to bring the challenges to us. China was giving it at a very low price, and that is why this technology was not absorbed by the industry. But right now, China is not giving. So if anybody wants to have these technologies, this has got a huge, impact when you are making IR imaging. It is used like a blank. So this technology is available with us, and you can see the CAGR for this is also very high. Another material technology which is available with us is the zinc telluride. It's zinc telluride. It's a single crystal which is available with us, and we have done EOI for this also. 4 partners have come, but if more people want to have such kind of technology, we can give this technology. This has got a huge potential for being used in terahertz. You can use it in terahertz spectroscopy. You can use it in terahertz imaging. And we have done imaging using these crystals. In fact, these crystals were given to TIFR. And when one-to-one comparison with the imported crystal was done, quote unquote, it was said it is 5 times better than the imported crystal. So this is the kind of material it is. Next material is silicon carbide. We have silicon carbide 4-inch technology with us, which can be really very, very useful for the upcoming EV applications which are coming forward. Another technology which we are going to offer in near future is the PMNPT. We have successfully grown PMNPT single crystals, and it has got a huge potential for underwater sensors. So these are the kind of things which we are doing at SSPL, and now I would like to touch upon opportunities and way forward. Uh, I am standing here and I'm talking about the technologies and the products which we can offer from indigenous sources. But yesterday I heard a lot that these things are not available. That is where we have to come together. We have to start using each other energy and start building totally indigenous solution. So what we have to do is we have to synergize research with the production agencies, and then the technologies which we are doing, although we are making limited numbers, but scaling up of the production is very much required. Because one challenge which we are facing is many people are asking uh, the products which you are giving from your technologies are costlier than what is being offered by maybe from China or from Europe or from USA. So if I have to bring down that cost, then I have to scale up my production. In limited series production, I cannot compete in price with them. So that is where I would like this forum to focus, and let us discuss this point, how to scale up this production, how to come out with completely indigenous solutions, because unless we make it totally indigenous, it is very difficult to say that we are there to make the Bharat Atmanirbhar. And since we are dreaming for Viksit Bharat 2047, it is very essential that my chips, my sensors, everything has to be indigenous. So thank you once again to the organizing team that they have given me a chance to speak here. And I really look forward for all the partners sitting here, that let's synergize our energies, because as dots we have energies and we are there. But right now, the requirement of this hour is these dots have to be connected. Then only a bigger picture will come up, and that bigger picture only will take us towards Viksit Bharat. Jai Hind, thank you so much.
So very good morning once again, and we will be moving towards electronics for the soldier support systems. So this will be presented by Mr. Devesh Sharma, who is scientist F in Sensor Development Division of DRD. He holds MTech degree in Instrumentation and Signal Processing. He has earlier worked in ADE, Nishant, Lakshya, Rustam, and now he is looking after design and development of chemical warfare agent detectors. So, Mr. Devesh, you can come over the stage. Before he starts, just a few lines regarding the soldier support systems. See, by far the most precious assets for the armed forces are nothing but the personnel who make up the forces. The troops have to work in some of the most challenging and hostile environment that the world had to offer, particularly Indian armed forces. And military operations goes irrespective of the environmental conditions. You must be knowing that if the pilots, particularly aircraft pilots who are doing all type of maneuvering, they have to wear NDG suits. Similarly, The submarines which goes into the water, they have to wear submarine escape systems. The troops who are going to the very high altitude in 1962 is something which was manifested where troops were ported from Chennai to directly to the Leh area. Unless we understand the physiology of the human being and provide the equipments, gadgets, which can not only upkeep their particular health, but also enhance their capabilities, will not be able to do the justice. So there are many gadgets which DRDO, particularly in the SSS cluster, soldier support systems, we make it, and electronics forms the backbone of many of these equipments. Today we'll be talking only about the equipment which has got some part as a electronics, and they are not only electronics. Let me tell you, these are the conglomeration of many of the different technologies. But yes, electronics enables it to make it smart, make it miniaturized, and also there is a lot of provision where AI and ML can play a role. Okay, so Devesh, you can go ahead.
Thank you, sir. Thank you very much for making my job easier with a very brief introduction. Very good morning to respected DG, respected directors, senior colleagues, ladies and gentlemen. Myself, Devesh Sharma, scientist staff. I'm working in DRD Gwalior. I'm going to brief you about the various activities which is being carried out by the Soldier Support Systems cluster to empowering the soldiers with the help of the electronic systems. Here we have the 6 labs and 2 centers under the SSS clusters, where DRD is working on chemical biological defense technologies, and DABR on military life support systems. DZR is working on avalanche predictions, and DIPR is working on human psychology and pilot selection systems. Coming to next, we will be talking about the CBR and defense systems, where we are working with a lot of electronic systems. This is one of the chemical warfare agent detectors which we have developed. It's a very complex technology. This is not only electronics product, it has a lot of pneumatic role to play. There's a deadly toxic chemicals which has to be handled by the equipment inside the systems, and they are so corrosive. If we don't handle it properly, it is going to damage the instrument. So we have developed the FCAT and PCAT chemical warfare agent detector. It works on the basis of the ion mobility spectrometry. This has got the microcontroller and microprocessor which takes care of the peripheral activities and the signal processing part. It has already been inducted into the services. Now to cater the requirement of the services, for the pocket variable lightweight detection systems, we have come up with an individual chemical agent detector called ICAD, which is a less than 1 kg category weight instrument and meeting all the chemical warfare agent detection, toxic and chemical requirement for the on-site detections. This is also works on IMS-based principles, and in the latest hardware, we are using a multi-core microcontroller, which is having a dedicated ARM processing cores for handling the peripheral and the processing capabilities. And as I mentioned, these systems are so complex in terms if the material is not inert and if it is not leak proof, they are going to give a lot of false alarms. So the technique involved here in the pneumatic design is very, very complex. This prototype has been realized successfully. Coming to the integrated protection systems, which we have developed, that is for the nuclear radiation detection from the DL Jodhpur and for the chemical detection system from DRD Gwalior. This is a system which is having a cyclone systems, heated inlet, and the blower supply to make the detector work in the tough terrain conditions. And this is based on FPG and microcontroller based designs. And we have successfully carried out the fitment integration activities inside the tank, and it is being equipped by the T90 MBT and the lightweight tank. Coming to the another technology which is also very complementary to the IMS systems, that is the flame photometry based detection systems. We have developed these detection systems. Prototype has been successfully realized, and it looks for the emission spectra which is on based on the sulfur or phosphorus, which is mostly contained by all the chemical warfare agents. So this is also one of the very prominent technology and has been successfully realized. Coming to the CAM-bio sensor networking, having realized those sensors independently, we have carried out the networking of the sensors to provide the wider coverage to the bigger installations. Now, with the help of the industries, we are providing the solutions to various strategic locations. Now, there is another requirement from the services to have the detection system mounted on the drones. So, we have the lightweight detection system which we are going to change its pneumatic design. to make it combined with the snorkel so that we can do the sampling of the contaminated chemical clouds in the air. So this is also one of the very prominent systems where we will be working, and we would be looking some help from the drone industry to work in the area to provide the support to DRU in terms of conducting the flights. We would be creating the chemical clouds, we will be doing kinematic design, but we need the industry's support for the various flight experiments. Coming to the another technology which has come out from the science and technology sectors, it is a colorimetric sensor array based chip, and it is also having a reader. So whenever this chip comes into the contact of chemical warfare agents, it changes the color, and based upon the changes in the color we can identify from the which group it is belonging to, which toxic industrial chemical or chemical warfare agent it is referring to, and depending upon the intensity we can identify what kind of concentration level is there in the field. There is no product available worldwide based on such technology, but we are seeing that it could be one of the systems which could offer us solutions on the lower cost. So we are pursuing this activity. Has got a lot of electronics. It is based on the single computer based design, and the prototype has been realized and being tested with the various chemical warfare agent toxin industrial chemicals. Coming to the BIOS part, we know how deadly havoc was created by the corona. So this is one of the most dangerous area where we need to work and we need to have our detection systems. So this is the system which provides us early warning for the biological threat. Whenever there is an increase in the biological load, we are going to get an alarm from these systems, and the sample can be collected into the sampler systems. So this is based on the LIA-based technologies, wherein the biological organs which is generating the spectra, the scattered spectra and fluorescence, that can be monitored, and based on that, with the help of the photo multiplier tubes and the photodiodes, we can do the detection of the systems. So the prototype has been successfully realized, and it is under the detailed testing and evaluations. Now coming to the identification of the biothreats, whether the biological load which has got increased because of whether it is because of bacteria, virus, or pathogens, that identification can be carried out only with the help of the identification system. So this is one of the state-of-the-art gold standard instrument, wherein automatically it detects the nucleic acid extracts without any human intervention, and it also amplifies based on the real-time PCR technology. So this is based on two components, the cartridge and the analyzer. So it automatically does all these activities and finally gives us the result, what kind of biothreat agent it was available. The prototype has been successfully realized, and it is currently under the testing and evaluation. Now coming to the filtration protection system, this is the system which provides the protection system to the safe houses, to the buildings, and regenerable CPW filtration system has been successfully developed. There is no requirement to change the filter system here. It can be regenerated, and it is based on the PSA-based technology. The challenges which we are facing over here is the reduction of the size, weight, and power, and we look forward towards the industry to further miniaturize these systems. Now, coming to another product, that is the filtration systems, which is providing a breathing protection to the fighter pilot in terms of the air which doesn't contain any of the NBC threat element. It is inline filtration systems, and which would be placed between the ECS and the ILSS, and it would be operable with the help of the manual valve control operation. Now coming to the life support system, which has been developed by the SSS clusters, herein the Devil is working in this domain, and we have come up with the onboard oxygen generation system centric integrated life support system. This is the one which produces the oxygen based on the direct supply of the aircraft. It has, with the help of this, we are able to get rid of liquid oxygen systems, and it has helped us in reducing the turnaround time of the aircraft, and also a lot of cost into the to the maintenance of the systems. Here we have the microcontroller based electronic control unit, which controls continuously monitors all these 10 LRUs and decides between the what kind of oxygen system, OBOX, backup oxygen system, or emergency oxygen systems, or what is the concentration of the oxygen. All these things monitors and being controlled by this electronic hardware. So this is also one of the very prominent systems, and the flight trials has been initiated in the LC aircraft of the ILSS. Coming to the next one, this is the external skeleton. This is a mechanically powered device which is wearable, and it helps in boosting the energy of the soldiers whenever he is doing some heavy duty tasks in the tough terrain conditions, and therein it helps the person. It is active and passive devices are available, and with the help of this, soldiers would be able to save its energy, and we have the electronic hardware which takes the data from the inertial measurement unit, from the EMG sensors. The processing unit, ARM-based processing unit, carries out the signal analysis and controls the actuator with the help of the servo controllers. So we have carried out the lot of lab trials has been completed. The TOTs are already given to the passive systems, and for the active system, TOTs are under the progress. Coming to the support to the ISRO's Gaganyaan systems, the sister laboratories has come up with the solutions which has been developed to monitor the health parameters of the Gaganyaan crew. The BioVest has been made ready. It uses the non-invasive electrodes to capture the various vital health parameters of the Gaganyaan crew and makes them available to the onboard system and also to the ground control stations. We also have come up with a food warmer and emergency survival kit. All these items are ready and it is available for the mission to be conducted. Coming to the next one, this is a personal flight systems which is controlled with the help of the pilot's body movement. It is having a IMU-based flight control systems for the stabilization of the flight, and with the help of the thrusters, the vertical takeoff and landing can be completed. This is challenging in terms we are looking to make the system more lightweight, more compact, and mission compatible. So, wherein the sensor fusion, multimodal sensors are required to carry out this kind of activities, and we have already developed a prototype which has been tested and evaluated for some flight duration, some flight altitude. We are ready to work along with the industry to further increase the flight duration and the flight altitude. So it's a very challenging activities. And coming next to the life-saving systems, this is one of the system which works on positive pressures, which helps the person in breathing whenever he's not able to breathe, not able to take the breath whenever he has got affected with the any kind of chemical or biological attack. So this system is already accepted by the army, and large numbers are under the projections. Now coming to the cochlear implant system, this is a device which helps the individual in hearing. It has got the two units. One is the external unit, another one is the internal unit, implanted unit. The external unit is containing a microprocessor, microphones, which takes the sound signals, converts into the electrical signals, and that get transmitted to the implanted sectors, which is fitted inside the ear, which again converts electrical signal back into the electrical pulses, and that triggers the optical nerve to create sound signals inside the brain of the human being. So this is also very interesting, very challenging work where we are looking towards the industry to take this work forward. Already a lot of work has been done in the lab. Coming next to the smart suits, we have developed two prototypes of the smart suits. One for providing the active cooling based systems to the crew which is working inside the tank, and another one which will be providing the optical warmth to the soldiers, to the pilot which is working on a higher altitude. So both systems has been developed, but again there is a scope of improvement, and we are looking towards the industry to develop for lightweight miniaturized compressors so that the quality of these products can be further improved. Now coming to the submarine escape suits, which has already been developed by us and being produced in the numbers, and we have also the underwater breathing aperture systems, which is also being under the lot of productions. Now we are looking towards the next generation systems, wherein we can have the electronic control for the smart breathing and also for the ascent profile control. So these are the systems wherein we would like to interact with the industry on developing these systems. Now coming to the one more challenging area, that is helmet mounted display systems. These are the systems which projects a lot of imagery, a lot of vital parameters, and various symbols on the skin, on the visor of the pilot, so that pilot can focus more on the task instead of just manually controlling those things. So this is the one of the area wherein we would like to work along with the industry for the optoelectronic design, for the opto-inertial head tracking, and optical coating for the visors. So these are also some of the futuristic activity where we would like to work together. Now coming to the brain-computer interface, this is one of the futuristic activity, and yesterday I was telling this is also available under the DSOE programs as one of the research vertical, wherein the industry can take help of the funding available over there. We would be using the brain-computer interfacing for controlling, like I mentioned, that exoskeleton systems to control it through the brain. So a lot of electronics need to be involved here. The neural systems, which is very weak, that need to be captured, amplified with the help of the signal conditioning system, and with the help of the system on chips, you would be able to process and analyze the data which is coming out of that neural systems to extract the features. Now coming towards the system which has been developed by one of our laboratory is a radar detection system, which is the all-weather real-time detection systems which detects the whether the avalanche is going to take place or not. This is the FMCW based radar, which is using a 10 gigahertz frequency, and we can do the detection up to the 3.5 kilometer distance within 5 seconds. So having a lot of electronics in terms of FPGA, DSP, low noise amplifier, pre-amplified, and down converters. And it is already being developed with one of the industry partner. Now coming to the next one, that is a harmonic radar, which is going to help the person who has got buried inside the snow. So for the identification of that person, we can use this particular systems. It transmits the signal in one particular frequency, and the RF tag, which is attached on the body of the person who's got buried inside, will be reflecting the signals on higher harmonic. So that would be detected by the transmitter, and the alarm would be getting generated. So it is an electronic handheld unit, which is going to be very useful, and we are already working with the industry, and the prototype would be available in the next coming year. Now this is another system which is being developed with the help of which is being developed for the requirement of the air forces. The prototype has already been realized. It is an automatic weather stations, and the microcontroller based hardware, which is able to monitor the various weather parameters like wind speed, directions, temperature, pressure, and humidity. So this has already been developed, and the detailed testing is under the progress. Another activity which is being carried out by one of our sister laboratory, that is the DIPAC, that is the computerized pilot selection system. So this is a system which is used to test the skills of the pilot in terms of the psychometer skills and the cognitive skills. So it has been produced along with the ADE Bangalore in the large numbers, and it has already been installed at the various Air Force Selection Board centers, more than 500 numbers. And we are also getting some of the interest from the foreign countries for the procurement of these systems. So with all that, I would like to coming towards the conclusion of my slides, wherein I would be mentioning again, the world is moving towards the miniaturization. We have developed the detection systems which was of 7 kg weight, then we have reduced all the capability, bringing down up to the 1 kg. Now further we want to go towards the 100 gram kind of size. So that is the one where the world is moving towards. Now we also want to work on the orthogonal detection system, sensor data fusion, extreme low power design.
Yeah, Devesh, time is over.
Yes, sir. And we want to have the indigenous SOCs available so that all this activity can be done. Thank you very much. Jai Hind.
Just to conclude the session, I would say that we have seen the miniaturized aspects of what we are talking about. And post-COVID, we know what the effect we had on our systems for our silicon-based systems. Today, I urge here, as what Dr. Meena Mishra brought out, on compound semiconductors. That's another area. And today I would also say that ISM, which is the government body which is funding the semiconductor mission, gives funding for putting up the compound semiconductor foundries in India, and government help can be taken for that. And we can look at having foundries that can enhance our capabilities in Make in India aspects totally, with technologies available in-house which does not require any uh, fees towards the technology. Right from the fabrication of the lab to the technology, how it has to be done, to the extraction of the device is possible, and it is supported by India's semiconductor mission. That is one thing I wanted to say. And as we heard from the life sciences branches, that wearables is the order of the day. We see how our watches have changed the way we look at our health, our progress, etc. And enhancing on that is the other aspects of how to take the physical conditions of the human forward for enhancing, either in terms of the energy levels, or in terms of better utilization of the human skills that we have into the soldier in the warfare domain. is another place where we are looking at it, and certainly it gives opportunities for people to come forward. And we know that we have a strong army. The numbers required are huge in numbers. That is where, unlike the radars or ESM systems, which are limited in numbers, the space is, I should say, the space is wide open. That is what I wanted to say, more than the contested space of what we see in other senses. So it's an invitation to industries to come forward. I think.
Yeah, so in fact, many of the portion of area which was not covered, let me tell you that small motors, still India is not able to make it. All drones which are there, bigger motors we are able to make it, but not the smaller one. Because we need it in large number, particularly for the exoskeleton. Exoskeleton, particularly passive, has gone, but then active exoskeleton is not able to get through because of these factors. Similarly, battery for the very high altitude at minus 40 degree, minus 50 degree is still something which is in demand. We are again looking for a lot of simulation. Maybe we are trying to conduct academia, but lot of simulation models are needed for the environment, for the physical, basically human different organs. You can imagine that we are having the simulation model for the 6 degree of freedom, where we do hardware in loop simulations and able to fly any of the objects. And maybe for the radars also there are various simulation model, but simulation model for human being different organs are needed. Whatever was shown, one exoskeleton will be needed, particularly the jet suit flying, where one person or the military person can jump from one hilltop to another one ship to another ship, particularly during internal conflict, wherever some trouble happens, person can jump from one building to another building. So a lot of requirement is there where human beings are there. Indian Army, whatever you say, it is more of human intensive rather than the technology intensive, and a lot of work is needed where we can partner. All of you can join us. You are knowing our numbers and other things. People can write their interest, and certainly we are going to engage. Thanks a lot. Thanks a lot to DGECS, DGTM, and everyone who is there here. Now house is packed for you. Thank you. Thanks a lot.
Thank you, dignitaries. Just 1 minute, sir. I request DGECS Dr. V.K. Das to felicitate our chair and co-chair. Thank you, sir. So I thank all the speakers and our chair and co-chair. I think with the right collaboration of these technologies, we can pave way for Viksit Bharat 2047. Next, we delve into the most awaited session of the event, hearing from our industry partners who bring valuable perspective from the field. Industries play a vital role in enabling DRDO to translate research into real-world defense solutions, fostering innovation, scalability, and self-reliance. On that thought, we'll begin our next session, featuring distinguished guests from industries to shed light on emerging trends, strategic collaborations, and innovations shaping the defense landscape. Our first chair for the day, Shri Pinaki Sen, who joined DRDO in 1993 and is currently working at DEAL, Dehradun as outstanding scientist. He has more than 30 years of experience working in airborne-grade RF systems and data links, telemetry tracking systems for UAVs and manned aircrafts, SATCOM systems, and SDRs. His notable contributions include development of the country's first generation of MSS briefcase SATCOM terminals, and his induction into the Indian Army, Navy, and Strategic Communications Network of the country. RF systems for Nishant UAV, AEWNCS, as well as Ship Data Terminal for Rustam 2 UAV. He was deputed to Antarctica in 1996 as a member of the 16th Indian Scientific Expedition for establishing the first picture transmission link between Antarctica and India, which was inaugurated by the then Prime Minister, Shri H.D. Deve Gowda. We welcome you, sir. Our co-chair for the session is Mr. R. Muralidharan, CTO Tata Advanced Systems and Professor of Practice at IIT Tirupati. He has spent 45 years in D&D of aerospace and defense systems, with 30 years in system engineering. He is currently focused on systems engineering of software-defined A&D systems powered by AI Fellow of Indian Academy of Engineering. To add to his accolades, Life SMI EEE, Fellow IAIIA member, CII National Committee of Technology, Innovation and Research past chair of IIT India, IIEEE India, Council and Bombay section, and past vice chair of Wireless Innovation Forum. We welcome you, sir.
Thank you very much, and welcome to this second and very vital and important session today. Now, yesterday's session was more focused upon from the DRDO side, where we opened up about the opportunities, the reforms, and how we can increase the synergy. And today's focus in this session will be particularly listening to the industry partners, their experiences, how the industry captains handle the problems, and how they deal with their set of issues and give us more deep insights. So there are 5 talks scheduled in this, starting from best practices for global competitiveness, ways to enhance the defense R&D ecosystem, the product lifecycle management, achieving efficiency in defense procurements, and the supply chain management. Now, these are very vital issues because after this Operation Sindoor, one of the critical elements that the country has realized is how to have the capacity building. Because once we go to the war, our resources also get depleted, and we need to scale up the production also very fast to keep it. And the trends worldwide, though we had a very short engagement in the military domain, but the trends worldwide are like this, that whenever such kind of engagements happen, they extend for a long period of time. And during that time, it is the vitality of the industries which help us give us a winning edge. So these are very important topics. If you notice that in the global scenario also, China at one point of time when the COVID was there, they had made a huge stockpile of semiconductors, to such an extent that the semiconductors were being deprived to all the other countries, whereas they had placed pre-orders of unimaginable volumes. So this is probably one of the reasons why today they have a bigger success story in scaling up the the bigger platforms that is being projected today. So let us hear more from all the industry partners. Before we that, I think your thoughts on this.
Good morning, and as somebody said, this is a very vital session, third of the series, 2 roundtables and 1 session from the speakers. So thank you DGECS for arranging this in your industry synergy meet. So very important session. But I would like to let you know that the military industrial complex, especially the private military industrial complex in India, is young. So we need some hand-holding, we need some mentoring, okay? The rest of the world, we still import 70% of our requirements, okay? So we have a very good scope to indigenize and supply those items. The industry is seeing that opportunity, but we still need some hand-holding. So if you look at the technologies are advancing, so we have an advantage that we don't have to learn the old things and unlearn it now. The industry is at the right position to learn the new technologies and adopt them and include them. So today we may be just manufacturing the technologies that DRDO develops, but tomorrow we'll be their partner, and we will take it from TRL 5 or 6 to TRL 9. And we'll start only with the POC with them, and then we'll produce it our own. We'll do our own system engineering, make the systems, upgrade on our own, and DRDO may focus more on the science to technology concepts, okay, with the academia. So with this, may I request the first speaker, Mr. Vinod.
So thank you very much. Let me give a brief background of the speaker. Mr. Vinod has a very good, strong academic background from India's premier institutes, NIT, KISC, NLSIU, and has more than 3 decades of experience into space, aerospace, and defense system in design, engineering, manufacturing. He has been recognized with awards, accolades, and he remains in this high technology, high reliability, techno-managerial roles. Has been a scientist earlier for the first decade of his career, and then a technocrat in the next 2 decades. Right. We welcome you, and I request you to complete your talk in about 10 to 12 minutes. Thank you.
Good morning, sir. Thank you for that kind introduction, and thank you, DRDO leadership, for providing us an opportunity. It's always a privilege to be amidst the scientific fraternity of the country and exchange what we think points towards enhancing the ecosystem, enhancing the scale of what the industry and DRDOs and the research institutions of the country can do. Clearly, yesterday and today are evidences of industry beat is not a tick in the box. It's a genuine interest of exchanging ideas, improving upon the existing scenarios, and making sure that we together work towards enhanced vision and enhanced footprint in the global scene. And the title of what I would like to speak, though the event calendar mentions about the benchmarks for global competence, but I thought I would not miss the main topic of the industry theme, which is enhancing the defense R&D ecosystem, and I will add how does that help towards global competence and self-reliance. Just 30 seconds of where I come from, an industry with last 25, 30 years of background, which is clearly delivering products to 25 different countries in design, engineering, and technology areas, both in designing and manufacturing products. So the innovation, electronic design, manufacturing are the inherited ingredients of what we do at Centum, with 16 granted patents, more than 150 publications. Technology focused to development, innovation are a culture, and our association with today's relevance of 25 years of continuous engagement with various centers of DRDO. And with that background, I would like to start with a question as to when will India produce its own Lockheed Martin, BAE Systems, Dassault, Rafale. The names that I'm taking are just, coincidence in nature, nothing specific to the country or the continent that I'm mentioning about these. But the interesting idea is when will we become one of these kind of companies? And what these companies represent, they are not just designing or manufacturing powerhouses, but they are delivering cutting-edge platforms, payloads for the world. And they represent also speed of innovation, depth of system design, ability to field world-class products. So when will India produce such industries for such ecosystem? If we deep dive that question into the next level, the natural thing would be, what would it take for India's defense progress to exponential capability? And that's exactly the reason we are here to talk about. And when we mention about defense R&D ecosystem, what does that mean? It means a situation or an ecosystem where we are talking about systems being autonomous, systems being high speed, systems being smarter, lighter, systems which are AI enabled, systems which are multidisciplinary in nature. And that's exactly the ecosystem what we are talking when we talk about defense R&D. Just a couple of examples of what does this ecosystem mean. It means even if you take in terms of smart sensors to cognitive systems, we are getting into areas where the command control systems are becoming more AI driven, more autonomous, more adaptive, more targeting in nature, more of area where cyber defense is also an area which needs to be coupled to make sure that this is progressing in the right way. So net, what does that mean? It means the overall situational awareness is increasing and the decision superiority is also improving. And that is exactly the area what we are talking about, and how do we improve upon the R&D ecosystem in India. Another example, even in the avionics side of things, right in design, testing and flight, we see significant amount of changes that are happening, transforming the way we think, transforming the way we test, transforming the way we simulate, and hence there is a need for us to look at how we can improve upon, how we can collaboratively work. And not to speak about AI. AI is everywhere. AI is here to stay. AI is here to disrupt. AI is here to challenge us, and we can't avoid that. And that's exactly the scenario where we need to embrace this and then try and use this to our advantage and make our systems better, faster, smarter. Another minute on just a rewind of how the defense R&D ecosystem has been in existence in the country. Over the last several decades, DRDO clearly has played a pivotal role in laying the foundation of the Indian defense technology. Absolutely no doubt about it. And the legacy of DRDO's innovation has been deeply respected, especially in the evidences of recent Operation Sindoor kind of events. The impact of what these innovations have created has also been very well experienced and appreciated. DPSUs too have been instrumental subsequently in translating the R&D into fieldable systems and platforms. We clearly see good number of DPSUs progressing and delivering systems which are rootedly designed with the DRDO and then are improved upon and are being delivered in larger numbers. However, in the last decade or so, we also have seen private industries, startups, establishing credentials in the defense ecosystem, contributing significantly. And the reason why we are here is to see how this entry can be enhanced and catalyzed to make it more impactful. We clearly see paradigm shifts from a DRDO-driven model to an ecosystem-driven model, where over the past decade, we clearly see a new energy in Indian defense innovation ecosystem, coupled with the policy supports such as Make in India, Atmanirbhar Bharat, support in the form of funding through IDEX, TDF. All of these are really enabling the Indian ecosystem to grow and then to contribute. The growing culture of startups with their disruptive ideas, fearless nature, out-of-the-box thinking, without-the-box kind of thinking sometimes, digitalization, digital-first approach, all of these are what we see as a paradigm shift. So further need for shifting the paradigm is in the areas of build to print to design to spec, design to co-develop, project-based to platform-based innovation, procurement driven to R&D-led engagements, and most importantly, the siloed efforts to collaborative systems. I think clearly the last one is extremely important for us to exponentially increase the impact of what we are trying to achieve. No doubt, alone, each one of is strongest, but I think together, 1 + 1 can make 11. So that's the scenario, and that internalization of how collaborative approach can make India a much better, a much powerful ecosystem is the need of the hour in terms of thinking, pondering, experiencing, and making it happen. We also do see some challenges in the face. Quick ones are, we still have a fragmented ecosystem, heterogeneous ecosystems. We have everybody coexisting. While that is a feature, it also can be sometimes a hindrance. So there is clearly need for institutionalization of these networks, which means mission mode co-developments, where each partner brings unique strength to the table is what is required. Another area where we need to see and where we see a gap is development cycles are too long because we are still thinking about sequential nature of achieving things. I think gone are the days where the textbook sequence forms are the best forms, because with the experience, with the increased maturity, there is a need for concurrent validation, concurrent thinking, and digital twins and model-based system engineering definitely will help in achieving these kind of things and expediting the overall life cycle of a development of a system or a platform. And hence, I think there is a need for us to look at this. Limited encouragement for long-term R&D investment in private sector. I do admit that while there is an increased R&D focus that is visible in the Indian industries, but I think still because of want of equitable stake or skin in the game for equitable frameworks, we still need to work on making sure that there is a stake and there is a reward kind of a situation. Policies, procurement practices must evolve to match the pace of the innovation. I think there is still a need for some amount of expedition, enhancing the speed, shifting of the gears in these areas, both in terms of funding mechanisms as well as the evaluation matrices. Talent, not to miss the talent dimension, there is clearly a gap between the academia research and the industry needs, not simply because it's a general talk in today's world, but especially the defense R&D side. One needs a blend of systems engineering, AI, embedded systems, and mission domain knowledge. And I'm glad to see a new course in this direction being started in the Defense University, is MTech in radar technology, which is practical focused, domain focused. And I think such initiatives are extremely important in making sure that we bridge the gap in the talent area as well. So clearly we need to see some new partnership architectures which are beyond development to order kind of scenario, where we see co-owning of IPs, sharing of risks, and definitely sharing of the rewards. We also need to see the policy and process reforms. While clearly these have started, these have begun, these have started showing some results, but I think to get a quicker impact, we need to see that the design weightage or the industry-led productionized environment is what is also given the right focus. Digitalization, like I said, is the need of the hour, and simulations, AI-assisted design, digital twins become the backbone of the ecosystem. And importance to these kind of things is also a need in the Indian ecosystem, so that this enables faster iteration, reduction of qualification times, because we see a significant challenge in terms of qualification time of the platforms, which is hindering the time to market or time to deliver kind of a scenario. And hence, digitalization, impact of digitalization, importance of digitalization to cut short this time by about clearly 30 to 40% is also a need. And thinking in these directions is also what is essential.
I request you to wind up.
Yeah, I will quickly wind up. So these are some of the areas where R&D is being done in dual use, having multiple impacts, is also very, very essential. So the transformational vision, if we truly want to be a Lockheed Martin or the Dassault of the world, we need to move from vendor to a creator mindset, compliance to an innovation culture, and a project-specific delivery to a long-term technology roadmap. And in this, keeping the topic of my talk as the focus, as to how do we enhance this towards global competitiveness. And I would like to just take a minute to explain the case study of my own industry, Centum Electronics. We have been exporting 75% of what we do to various parts of the world. And what are the success recipes? We do ship to Airbus, Safran, Thales, and what are the success factors in these? Basically, these are broadly classified into two areas, which is the design development side, where we happen to be the platinum grade engineering partner, and on the manufacturing side, which is also equally important to have the right set of manufacturing ecosystem. So the point here and the key success factors are clarity in the scope of work definitions, the change management clauses, the timeline expectations, the pragmatism and the flexibility, and the traceability of changes. I think these are clearly the differentiators what we see when we do execute work for the global nature, and the depth of documentation, contractual terms, design lifecycle management are clearly the differentiators. I think it would be good to have an excluding session on as to how exactly are these, but I think I'm intending to give some pointers here. So overall focus and importance to these aspects while we execute complex products, respect for each other's times and the work scope is what makes a different success factor for supplying to the global needs. Not to forget about the production side of things or the manufacturing side of things, where the input documentation available, input conditions available, input debug flowcharts available are so strong that what designs have been done 15 years ago, 18 years ago, 20 years ago are person independent. They don't even know where the designs are getting manufactured, and they are exactly seamlessly manufactured in large numbers and delivered without any compromise in the reliability. I think these are the areas, and if I have to summarize those recipes, I would like to summarize them. If design in India, develop for the world, deliver with excellence, if that's our motto, I think alignment to global standards, making sure that we understand the importance of the process maturity, benchmarking the SWAP, agile R&D model, concurrent engineering, stage gate and R&D governance. Each stage and compliance in the checklist of each stage must be followed exactly verbatim, and that discipline is the key to success. Designs for reliability, of course, multidisciplinary R&D teams, and digital engineering, like I said, are the key success factors. So net, we have a transformational vision where mission integrated ecosystem is the need of the hour, where DRDO can set the visions and standards, industry drives design and manufacturing, academia can fuel research, while startups can inject agility. So the last slide, defense R&D ecosystem, last decade has been one of building capability, and the next decade should be one to build the leadership. So the vision, policy push, and new generation of engineers are keen to design for India and deliver for the world, and that exactly should be our changed motto. And as DRDO partners, DRDOs, in DPSUs and industry, together we need to, and we have to, and we must pledge to create an ecosystem that not only meets our defense needs, but defines the globes for benchmarking in innovation, quality, and speed. That's what I had to say. Thank you so much.
Our next speaker is Mr. Kukku Swami from Data Patterns. Well-known figure, mostly in CNCs. Right? He's a BTech in electrical engineering with almost 30 years experience in business development, and in which 25 years has been more in data patterns. He has got a huge exposure to MOD, Department of Space, handling foreign OEMs and whatnot. Because of shortage of time, I'll ask him to more focus on the lecture. Please restrict it to 10 to 12 minutes because we are running short of time. Please go ahead.
Thank you very much, sir. Good morning to all. First of all, I thank DGECS and the ICS cluster for us to give this an opportunity to talk about way forward towards building a defense ecosystem. So that is a topic that is given to me. Sorry, I have not made any presentation kind of a thing, sir. I just wanted to express the ground reality. Yesterday, there are a lot of points which industry wanted to say. It has been stressed. Probably, I think there could be some repeats, but I wish to talk Mother Earth or ground reality aspects, sir. Like whatever we are today. See, finally, our customers are MOD together, DRDO or industry. Our customers are DRDO. So if you are on time to meet DRDO expectation and finally the MOD's expectations, I'm sure I think there won't be any import per se. Of course, we are heading towards that along with the DRDO's push and the industry's ability to build the systems. So the issues why defense ecosystem is not up to the mark or the expectations. What we feel is what is happening now is there is a lot of crosstalk kind of a things. There is no barrier between tier 1 or tier 2 or a tier 3. Today, what is happening is tier 3 is pitching into tier 1 kind of an opportunity. Tier 2 is putting themselves into tier 1 kind of an opportunity. With this, what is happening, a tier 1 would like to really migrate to the next level. So they are unable to do because they have to compete with a tier 3 also. So finally, like yesterday, someone was mentioning, if there is a concept of T1, and of course, L1 is important, there will be a sheer segregation of who can do what. And if there has to be an engagement model for each of them, we need to really decide what is our end objective. Meaning, are we attempting to do a product development or are we attempting to do vendor development? If there is a difference between these two, I'm sure, see, there has to be an engagement model for vendor development under TD, if you have to ask. Then in a method where the investment flows to the startups, for example, they can get engaged in TD and they can migrate to the next level of mission mode kind of a thing. But what happens to organizations who are already ready? See, DRDO has built industries with their review mechanism or project reviews, etc., and made an MSME to some kind of a next level who was building parts, subparts today, full-fledged systems. What happens to them? What we see today in the industry to all is all are allowed. See, one can do, everybody can do. That philosophy is there. So if that is the case, then it becomes only a commercial competition. So we feel, I think, to build a good defense ecosystem, there has to be a roadmap for all the industries who can really work seriously on investments. See, if anybody has to grow, there is a need for investment. How industry will do investments? If they know what is there tomorrow, what is there next year. So finally, industry works for business, there has to be a profitability. If that has to happen, how do they do that? So if a roadmap is available to each category of industry, so then there can be an investment and an engagement model per se. So now it is becoming like a market kind of a scenario. Well, all are there and all kinds of activities are being done by everybody. So if we can avoid this, I think there will be a lot of incentives to company like us, for example, Data Patterns. We would like to really go full hog on next level of investments to see that, okay, we are ready with DRDO when they want. So if there is a roadmap available, a company like us, many companies here would definitely invest and see that, okay, we can cut down the timeline. When services wants, we along with DRDO, we can definitely be there on time. So because systems are not available, MOD is going towards an import option. So this is one thing. Another thing is what industry looks for a support is like ISRO works in a GOCO model. So government-owned company operated. So if the access to the DRDO or MOD infrastructure to startups or MSME or a large-scale industry, that will cut down a lot of investment-related aspects. So we can quickly adapt, we can quickly use the facilities and build end systems at a faster timeline. So this is another thing. So exposure to the next level technologies through academia, there has to be some kind of a mechanism where industry, academia, and DRDO or MOD all has to work in a collaborative method. It is happening now, but not probably at the pace what our MOD wants. So can there be a procedure or a process which can expedite these kind of enablers? So with that, I think things can be made faster. And roadmap for next 5 years, 10 years, if industry gets to know, and this is the investment that is required, surely industry will definitely support. It is like chicken and egg kind of a story. Now what is happening is everything becomes a tender mode, and who gets the tender, nobody knows. So with that, investment doesn't happen. Because no investment is happening, the ecosystem is not happening. So why industry should invest? So that question comes from an investor point of view. So for example, the board of directors, for example, in any listed company, they ask why we should invest. So there is an outcome, return on investment they ask. So if that is the case, a roadmap and hand-holding by DRDO will definitely help industry to invest a lot and work towards the next generation technology. And of course, whereas in the foreign place, what happens is there is a genuine handholding. Okay, a company which has an expertise in some specific field, they are not allowed to go to a different field. So with that, what happens in the same domain, the industry continues to spend time, energy, and invest so that, okay, they go to the next level. So from subsystem to the full system. And when the crosstalk happens, everybody can do everything. So that if you can curtail, I think in a specific domain, every industry can become masters with the help of DRDO's domain knowledge. And yesterday, we also requested if there is a possibility of DRDO extending the consultancy, then the huge systems at a system level, possibility of industry doing the systems which can be exported. So we need to see that, okay, how to commercialize DRDO technologies through an industry which can be exported. If that happens, there will be a real fuel within the industry to invest more and build more. So with this small talk, sir, I just want to take some questions. I am talking not 30,000 feet kind of a view. I am talking Mother Earth scenarios, which will really help industries to invest and see that, okay, how we can be closer to DRDO's expectations, MOD expectations, and finally we have to satisfy our customers. This is what I want to say, sir.
Thank you so much. I think I request all of you again, if you have all the question answers, a Google form is given. Please fill it up. During the round table, we will address all of this. Thank you.
Thank you, sir. Thank you very much.
I request Chair and Co-Chair to felicitate them.
Our next speaker is Group Captain Naisetti Srinivasa Rao, Senior Deputy General Manager from L&T. Mr. Rao has joined L&T in the year 2023 after serving as a commissioned officer in the Indian Air Force for over 2 decades. He is an accomplished professional with more than 25 years of experience in air defense systems and air defense radars in particular. And he also spent a lot of 8 years with the DRDO as a user representative for radar and command and control systems. Srinivas clearly understands the issues associated with the life cycle management of defense products. So inviting him to share his thoughts on how industry and DRDO can synergize.
Thank you so much, sir. Good morning, everyone. After serving about more than 2 decades in Indian Air Force, I've joined L&T in 2023. In L&T, we have precision engineering system, which looks after the defense part of the business. And under PES, we have 4 verticals, basically, looking after the interest of the land systems, naval systems, and the electronic systems, and these aerospace systems. I come from the electronic systems. Ours is EPS, Electronics Products and Systems, and I'm heading the through life support for the EPS business. I would like to cover the topic as flashed, and I'm not going to cover about the software part of the PLM because most of us are aware that the PLM software needs to be robust and it needs to have all the checks and balances and which can connect from the concept to the time it is being designed, handed over to the user, and it is through life support. So my talk will be majorly focusing towards the processes related to the PLM and what are the challenges in these processes and what are the what can be the some kind of actions which we can take to overcome these challenges. In a nutshell, the product life cycle is the complete, in a defense sector, is a holistic approach to manage equipment from cradle to the grave. It starts from an idea of a solution and it continues with the induction of an equipment and it terminates when the equipment is decommissioned and it is taken out from the service. Indian context, the PLM process starts with the strategic national security strategy, which gives the policy framework for both the armed forces and the DRDO to develop a new equipment, new weapon system, or to initiate a procurement for new weapon system to address the current and the future security challenges. Next slide, please. And we are aware that we are in a VUCA world. It's a highly volatile, uncertain, complex, and ambiguous. And we have seen the recent conflicts. This could be a very short conflict, like Op Sindoor, or it could be short and the intense, which would be like between Iran and Israel, or it could be a long-drawn process or the long-drawn war between the Russians and the Ukrainians, or it could be a total war. As a nation, we should be prepared for all kinds of situations, and each type of a war requires a different kind of a preparation, a different kind of equipment, a different kind of a procurement. So the industry needs to continuously observe, orient, optimize the resources, quickly prototype, and offer whatever is a solution available to the user so that he can address the current situation immediately. The efforts are being made towards this direction by introducing a concept called as emergency procurement, but it has got its own the problems. Next. Further coming to the challenges, I would put the challenges into the PLM process into two major baskets. One is the acquisition basket, and the second one is the product support basket. The acquisition starts with a user thinking about a product, thinking about an equipment which need to address an operational scenario, an operational requirement, and thereafter he initiates the process, and the process continues for, if everything goes as per the book, the process is supposed to be completed within a 78 to 125 weeks. It never happens because of various reasons, because there are about 12 different phases. Each phase is a make or break up for the project. So it takes a continuous, majority of the projects are delayed or approximately takes about 5 to 6 years of fructification. But the challenge is, sir, once the user has got something in his mind and he wants a equipment which addresses that particular situation. However, that information or what is there in the mind of the user is not properly translated into the design, or it's not properly translated to the developers. Now there is a gap between what is being perceived as a requirement to what is being understood as a requirement and what is finally being delivered as a requirement. So we have a huge challenge in this. And the protracted, as I've covered, the process of initiation of a project to the induction of a project and the life cycle of that project is about from 25 to 30 years of cycle. And there is an issue with the TOT from the DRDO, which I will be covering later. And the next part is the product support, which spans about 20-25 years. Without an assured business of continuation of a business, the industry is not in a position to invest additional capital, and it is the industry is based on like the lead integrators like L&T. We have an ecosystem which are supporting us to make the subsystems. Now, if I don't have visibility for the next 15 or 20 years of a business, how can I support my sub-vendors? Now, the vendors are looking at me, and I don't know whether I get the next contract or not. For the next contract, I'd have to once again fight for the L1. Next slide, please. The proposal, I'm looking at the proposals are the proposal for addressing these challenges. I'm proposing three major proposals. One, to have more interaction between the user and the industry and the developers. And the second is to address the TOT, and the third one is how can we manage the through life support system. The interaction, because there is a security curtain between the user and the industry, because user never shares the information with the developer, because every time he looks the developers in a suspicious eyes, whether if he shares the information, whether the information, what kind of how the information will be utilized, there is always a suspicion. So what we propose is, could please click on the hyperlink. So we are proposing a national security clearance for defense industry personnel. As a defense industry, we are supposed to have a ILDC license. This is industry level. Whereas once the industry is ILDC certified, ILDC licensed, we have different categories in ILDC based on the equipment which you are manufacturing. If I am only providing the services or I am doing only the logistics part, I am at a different category. If I am supplying a sensitive equipment, then I am different category. If I'm a partner of a strategic system or the strategic program, I'm at a different level. So based on the level in which I'm playing with I'm doing business with the MOD, I can be given the security clearances. The security clearances could be at three different levels. Level 1, which talks about the confidential, which enables the user to share the confidential information. Level 2, wherein the user can share the secret kind of information. And level 3 is the top secret national security clearance for the individuals operating in the industry, wherein the user would be able to clearly and he will be able to share the sensitive information. And we can mutually work out a framework and suggest certain things to the MOD also, how this can be taken forward. Back. The next part is next is the TOT. We are very thankful that we have a defense R&D organization which handholded the R&D, the defense industry, and which has been doing a great work. However, we have certain challenges in this. The TOT which I'm getting from the DRDO, I would expect a comprehensive a TOT including source code. Once a TOT, it can include the complete cost of technology development. Once I get the TOT, I want the TOT. Now, with my R&D and with my capability, I should be given freedom to modify, enhance, and do my value addition. This value addition would be a game changer for that particular industry. And I should be able to freely select or develop my own sub-vendors and my own production partners, so that I make my own ecosystem, and with my ecosystem and my value addition, I would be a differentiator in the market. Otherwise, it becomes a commodity. Once you are given and everyone is available, everything is available to everyone, and it becomes a commodity. Commoditization of a defense industry, defense products is very, very, it may not serve the purpose which may not serve the purpose. With this, if we have this kind of a system, the user is will be benefited, because he is going to get a different variety of different solutions for his own problems, and at very affordable cost. And the next slide. The third part is the longevity or the sustenance of the business for an industry. Like if, let's say, after going through the entire the selection, the acquisition process, I deliver one equipment to the customer. Now I have about 2 years of warranty with him. Thereafter, I'm not sure whether I'm going to get the EMC for that equipment or not. Now I have developed an ecosystem with my sub-vendors, my tier 2 vendors. Now with this, how can I sustain, my sub-vendors are looking at me, if you don't give business for next 15 years, what I'm going to do? Now, to give him some kind of an assurance that, okay, you are going to have assured business for next 15 years, I need to have a maintenance contract or AMC kind of a thing with me. Because gone are the days when the majority of the equipment is being imported from outside. So the BRDs are the base depot depots have been created to support those kind of the maintenance activities. Now we are maturing, the industry is maturing, the people are available, the trained people are available, so the industry is ready to take on the maintenance burden from the forces so that the forces can concentrate more on their the primary job. And there is the forces or the user has got a problem in giving the maintenance contract. He says that if you don't give me the product, if you don't give me the service in time, then my operational preparedness is compromised. Now we can, as an industry, all the stakeholders can decide on the SLAs which can meet the operational requirement of the user, and at the same time we also make some kind of sustained business in the future. The existing, the earlier speakers are also spoken about the utilization of the existing infrastructure of either the R&D or the user. We have a huge infrastructure available with the users in terms of the BRDs, and those facilities can be extended to the industry so that the industry can set up their own the maintenance of facilities for product support, and this can be a sustained model for the long term. Now the last part is the obsolescence management of the software, because the software is because of the improvements in the hardware changes after every 2 or 3 or 4 years. Every time there is a hardware change, then you have to once again do the entire software thing. It becomes very, very difficult. So we can think about the hardware abstraction layer kind of a interface between the software and the hardware, so that the software becomes independent of the hardware. That's right. Well, the way forward of the defense manufacturing industry is a vital element of national security, because now once we talk about the war-waging potential of any nation, it is encompassing the armed forces, the industry, everything. So we are a vital part of the national security. This need to be understood. This need to be realized by everyone that we are also a part of national security, vital part of the national security. And because of the drive for Atmanirbhar in defense equipment manufacturing, and we would be able to significantly contribute to the Vikasit Bharat 2047, wherein we want to have 13 trillion kind of the economy. And the few existing, with the few amendments to the existing framework, policy framework, we would be able to deliver what the user and the nation is expecting out of us, and we would be working towards the national objectives. With this, I've concluded. Thank you so much.
Request chair and co-chair to felicitate the speaker.
The next speaker is Mr. R. Harikumar, Director R&D at the Navaratna Defense PSU, Bharat Electronics Limited. Mr. Harikumar was earlier General Manager Technology and Planning prior to joining the board of the BEL as Director R&D. He joined BEL on a May Day in 1989, and he has over 3.5 decades of experience. A lot of accolades in Bell, did a lot of things. It would be difficult to read out all of them at this short point in time. He attributes all his successes to his performance and growth to exceptionally committed past and present seniors and colleagues. Over to you, Hari.
Thank you, sir, for the introduction. Good morning to the session chairs as well as the dignitaries in the audience. This is the topic which I'll try to cover in a short time. So achieving efficiency in defense procurements, development contracts, the role of industry partners. Okay. Bell and DRDO go a long way back. In fact, Bell started a bit earlier than DRDO, 1954, and 1958 I think DRDO was formed. So we've been there with DRDO, and we will continue to be there in supporting the self-reliance mission. Defense requirements, as many of the previous speakers also brought out, are pretty unique. That is a difficult part because selection of components, materials, the stringency of the specifications, shelf life conditions we put, screening requirements depending on the project. So that is a stress that we put on. The operational environments are tough. The longer evaluation cycles, as many brought out, and multiple trials, winter, summer, sometimes repeat trials, and again the order acquisition time is longer. So again, what happens is technology obsolescence along with component obsolescence or module obsolescence sets in. So the longer product support duration is another cycle. Several, as again brought out by many of the speakers, 10, 15, 20, 25 years, depending on the product. So it again is a big challenge in a time when a couple of years is sufficient for a technology to be outdated. So it is very, very tough for us to, as the industry, to maintain defense products this long. To add to that, in defense manufacturing, there are global majors now setting foot in India in a big way, not only in defense and now, design and also in manufacturing. And Indian manufacturers now need to really stay, to compete with the best from all over the world. The quality standard expectations are also very high. So again, compliance costs are higher. And the lower volumes when compared to commercial or industrial sector. This is another big hit for the defense industry. And the product mix generally is not very amenable to mass manufacture or automation, not too much. Although there are cases with array-based solutions coming, there is at least some volumes we are seeing. Customer expectations continue to increase, more performance at lower cost. That is a given nowadays. And the other problem that we see is, as I said, the longer development realization times also lead to changes in the minds of the customer, or the demands change. So design changes come in, which again the costs increase for the industry partner of DRDO, or if it is an industry which is developing on its own too. So one of the points in, say, for example, DRDO development tenders is that there is always of getting the input requirements right, and this is true for any contract, but especially in a development contract where it is expected that the requirements will change, it is even more tougher. So this is more of an idealistic slide, wherein the trying to understand the floated requirements is one, and also seek clarifications as early as possible and as much as possible, also during, before and even during the pre-bid meetings. This is, and also minimize assumptions, and if assumptions are there, one unavoidable, document that, And because without clarity, our bids wouldn't be valid because it will be totally out of sync. The other two again are very difficult to, but it's an idealistic where the realistic costs have to be put in, including the bill of material, the fab, the assembly, the tooling, the testing, the qualification, all the costs involved which are repetitive, and the non-recurring ones for design with provision for iterations, consultancy, tooling, trials. In fact, what happens, as was brought out by one of the earlier speakers, is that multiple compromises occur at this stage, especially in costing, and that puts the DRDO also in a spin in the process. Time estimation is another where the complexity is either ignored or sometimes let go to just meet the timeline specified. So these are not unilateral statements. The industry alone cannot do this. The expectations of the development, the design agency like DRDO should also be realistic. Otherwise, it becomes very difficult for the industry partners to be pragmatic in this kind of state. In terms of manufacturing and support, again, designing for manufacturability as well as maintainability is very key. Ease of assembly, testing, and even the same way repair also. Repair, troubleshooting also should be there, so that, because maintenance is one of the important aspects of any defense equipment. And standardized modules, building blocks will help a lot in configuring systems faster and maintaining them also, because spares would at least be easier. Automating assembly wherever possible would help in getting repeatable higher yield. Built-in test features can be incorporated for troubleshooting again, and predictive maintenance with AI available now is another feature which many of our systems now started taking the benefit out of. Single source dependence is a big danger in military, which we are seeing across the geopolitical has really thrown that apart. We are facing quite a lot from denials of technology or products because of the local wars being fought in Russia or in Israel. A lot of supply chain gets badly disrupted. So this is something that if in the beginning itself we start looking at it, it will be much better for the nation's security and defense. Obsolescence is another issue because of the long support cycles and long procurement and support cycles involved. So this is again, so during the design phase as well as during the manufacturing support phases, this is incumbent on the manufacturing entities to look for this and take help of DRDO or their own to implement this. Obviously, customer expects long MTBF duration, very short MTTR mean time to repair, ruggedness, long-term maintenance, all are, the best of the best is expected. And also ergonomics nowadays we are seeing that that's also being stressed for the conditions of usage. Upgradability and the need for variants to meet when new technologies emerge to involve that, and also different user environments. Again, defense production challenges are multiple. Import dependency are very critical, as was brought out in the early morning session. Semiconductors, IR detectors, high power microwave tubes, rotary joints are some of the examples where imports virtually dictate the time of manufacture and the cost of manufacture. And increasing indigenous content again is a challenge because again long cycle times for evaluation. So this is something together the forces, DRDO and the industry needs to evolve so that faster qualification and shorter times for induction should be there for indigenous products which are even indigenized later. Single source, again, as I brought out again, needs to be addressed, otherwise it can become a big bottleneck. But again, when an alternate source is developed, how quickly can you get it qualified and introduced. That is again a challenge. Again, this was a point that we brought out again. We need to keep training personnel because technologies are evolving, and in all the segments, that is whether it's software, hardware, system level design, integration, all areas we need to have personnel trained because the educational institutions are not able to do that ready off the mill. You don't get them ready. So that is where again industry needs to join hands with academia and make sure that people are more practically oriented when at the student stage itself. Building manufacturing capabilities is another wherein but this is again not contingent on the volume or multi-use of the same facility. So this is something again we need to build up. Some of the best practices we've seen is when we were able to do advanced procurement of critical materials and the anticipating orders, we are able to do things faster. Otherwise, it becomes because guaranteed orders are not there all the time. So that's a big challenge. And even extending support to our partners, vendors, for example, in doing some qualification or getting raw material for them. These are which we extend again. We have found that all these help in reducing the time cycles. Then tools, analytical tools help ensure that the design is more centered, and in large number production, there are less variances. So this is another area. And another important part is where the evaluation tools and simulators also help speed up system verification. This is automation wherever possible of both assembly and testing. In, for example, in active array radars, it's more easier where both assembly and testing can be automated and made faster and repeatable. Customer requirements for the particular use case, the deployment, if it is understood well, then activities and facilities can be accordingly planned. Timely completion obviously is a requirement, and together with customer and DRDO, if industry works as a team, it will be much better than in working in silos. I've seen, for example, that some of the best firms in the world, the defense majors, for example, Thales, puts a lot of stress on process compliance, and they don't put so much stress on things like testing, tweaking, tuning. All that is not done so much. So that these are very technically cost intensive and people skill intensive. Those are avoided by making sure a process is under control and a repeatable process is maintained. So that's how he makes sure that, for example, the TR modules on the airborne radars are meeting all the specifications. So in conclusion, it is not an ideal world, it's an imperfect world, and there are no permanent friends for the country. So who is a friend today may stop supply. So it is very, very important that we become self-reliant in critical technologies, in critical components, where there is a chance of single source. It is very, very important, and that is a non-negotiable part. Indian industry, because of the requirement of volume, India is a growing market, but still not sufficient to keep the industry waiting for the business. So it has to be a mix of export and serving Indian requirements. And if all the three, the design agencies, DRDO, the customers and industry work together, I'm sure we can make a winning combination for the nation in terms of defense, both the development side as well as on the manufacturing side. Thank you.
I request our chair and co-chair to felicitate our speaker.
our last speaker for this session is Mr. M.V. Reddy. He is a graduate in electronics engineering and a postgraduate in business administration, and has over almost 30 years of experience in heading business operations in defense, space, meteorology, and telecom segments. He forayed into the electronics, strategic electronics domain, and started working as an engineer in ECIL in 1990, then under the Atomic Energy Department. Then he utilized his opportunity to gain valuable experience and working on various technical platforms. And he subsequently moved on to Astra Microwave Products Limited. Is a very well-known entity in the defense circles, right? And he's been there for almost 25 years in key position. He's a firm believer in Industry Institute Corporation. Under his leadership, Astra Microwave has been working on several institutes in collaboration with RF and microwave domain for which it is very well known. He was one of the members who set up a microwave lab and training facility at the Osmania University in Hyderabad in order to get trained people from the microwave engineering. This is a field where there is a lot of dearth of talent in the country. The microwave community, of course, in the last 5 to 10 years, it has come up to a fair extent, including a lot of courses being done. He's also holding an honorary doctorate degree from Vijnana University, Hyderabad. I request you to commence your presentation and bring it off in about 15 odd minutes. The topic is very vital, supply chain management, because this is where DRDO also comes into play. Once we think that we have wiped our hands off, given the product to the industry, TOT is done, then the supply chain sometimes poses issues. The design is not up to the mark for some reason to, upgrade the obsolescence management. The industry gets back to DRDO saying that, no, I want your support to, change this component and this and that. Whereas the people who have been assigned the job, they're moved up somewhere else. So this is a critical area. So you can please share your thoughts on this. Thank you.
Sure, sir. Eminent dignitaries of DRDO, fellow industry friends, ladies and gentlemen, a very good morning. The outset, I would like to thank DGECS and ECS Cluster for giving us this opportunity to participate in this wonderful event, Samanvaya. A synergy between DRDO industry for the first time, in fact, I saw in this ECS Cluster, and the response is really huge, and in fact, I'm really very excited to be part of this. And I feel honored to be part of this particular session. And the topic was given to us to share our views in supply chain management. As Dr. Pinaki Sen had rightly mentioned, it is an important subject, and also though it looks to be very simple, but very challenging, and in every aspect of the complete, the growth of the technology and as well as the nation. Well, today, in fact, I would like to cover this particular point as not as a process issue, but as a strategic lever for India's emergence as a world superpower in defense technology. And I would like to just touch upon few key points, how industry, DRDO, and even armed forces can work together to build a self-reliant and globally competitive defense supply chain that supports rapid innovation and as well as reliable delivery. Yeah, as I said, what are the key challenges and then also the solutions and way forward. This is actually like, when we discuss about the, systems at armed forces, as Dr. Pinaki has mentioned, like the process delays in the timely induction of required platforms and systems leading to capability gaps. They always say that, the projects are taking many years from the requirement definition to the delivery. And also because of these long timelines, by the time equipment is getting delivered, they always say that it is either partially obsolete or even the threat environment also must have been changed. These are all some of the views which in fact we have been listening from the armed forces. But why these are all like it's happening this the frequent spec changes, especially like from the date of formation of the QRs, we have been seeing many times they keep changing the specifications, and sometimes they are introducing the gold-plated requirement that is very like as ambitious and high-end spec in the initial stages, and they've been keep on changing the QRs. And also during the execution phase, also we have seen sometime many times changing the specifications is leading to the delay, and as well as it is impacting the cost. Also, like although there is a significant improvement in the last few years, but we still this bureaucratic overhead and multiple sign-off, industry is not in a position to plan it properly, and as a result, the entire system lacks the agility. Why these are all, what are the factors, major factors which are contributing towards this is lack of strong ecosystem in India, and then technology gaps. Let us accept the fact that still we have technology gaps and expertise in India which we need to be addressed. And of course, geopolitical situation, as our previous speakers, a few of them have already highlighted about. We really, it is difficult, today to believe who is friend, who is not a friend. Like we never know when they stop delivering the products, or how they stop the delivery of the components. So these are all something which has become a real big issue. And then import dependency and critical raw materials and components. As yesterday CMD Bell had mentioned, today, in fact, I would like to emphasize on this point, is a very important point. We talk about self-reliance, especially in the electronics. We do all the design part of it, and also we supply subsystems and then even systems. But how about the basic electronics, semiconductors and the components? We still depend on the US and other sources, the Western and Europe sources. In fact, sometime, to be honest with you, I go through like sleepless nights, even recent past. I understand that there are, I think most of them are electronics industries they're representing here. We still import basic tantalum capacitors, which is not available in India. And there was a shocking news about a couple of weeks back. There are two major companies who have been supplying world over for over decades. They say, I think it may be difficult after a year or so, it will be difficult to supply these components to the Indian market, as they've been getting feeler from the government to put embargo in a phased manner. It is really big shocking news. So where do we go then if this is the basic components, if they block to supply the countries like India, then it will be very difficult. So fortunately, the government took some initiatives in recent past in setting up of the foundries, and also some basic infrastructure, and they're giving the tax benefits and all. But still, there's a lot to be worked in this particular domain, because without basic electronics in place, neither we can talk about self-reliance nor we can talk about a continuous supply chain. So this is something which is very important to be noted. And of course, unhealthy competition. In fact, this is something which, although many companies may not like it, but I have seen in the last 1 year, 1-2 years, it is something totally different kind of a mechanism that has been, we have been witnessing it. Many startup companies and small-scale industries and all, just to in the verge of getting orders, they're getting predated pricings and all, which is not a healthy sign actually. So they should build the product technology, and then they should go to the market, rather than getting into this kind of a thing and then going to the investors with the valuation sake of thing and then getting an investment. But till that time, project can't wait, and even customers cannot wait. These are all something which is really bothered. I think probably we must. I can also give you a solution to that. Not only the problem, but we have to maybe in the RFP itself we have to mention that any company who is quoting a particular price should have maintained at least for a minimum period of 10 years, maybe with the inflation rate and foreign exchange. Those are the two key variable factors probably we can incorporate in that. Then probably these kind of things cannot be attempted. So this is something which is a serious issue. What we've been seeing, some of them have started with quoting 1 rupee for a big system, and some of them are 4 rupees. I don't know, maybe it's going crazy. And that finally what will happen that, whether they capable of deliver the product or whether they can do that within that. So is there a sustainable model is working, or it's all question mark. Like, we need to see. This, I think, is only last one year or so we have been seeing this particular trend. Then, of course, then on the other side, the companies are coming out, industries are like, how we get sustainable. In fact, yesterday DG ECS also, in our panel discussion, he asked us, having developed a niche and critical technology, what are the models that Astra has adopted, toward the sustainability? Like one way is what I have mentioned is the diversity, like, the offshoot of this technology we are using for the other applications, like for the space, meteorology, and even other sectors, so that at least our business continuously will flow. As we all know, defense, whatever measures we take, world over, the gestation period is too long. In spite of what are the policy we create, what are the framework we create, the gestation period is too long. So we have to work out a model where our company should be healthy, like diversify your product into the different segments and then address those markets as well. Then some of the what are the procurement models or methods we can probably seriously look into that. One is that in US and Israel, what they follow is spiral development model. This model is basically they try to create a system or platform product or equipment with the critical needs first, rather than getting into all in one time. Then thereafterwards, they can keep on upgrading based on the technology, evolvement and all these things. So here we are, unfortunately, we wanted the best, whatever is available in the world, in the or whatever it comes to their mind as the first model itself. It will be very difficult, and the time taken during the development phase will be too long in order to address those things. So this is something which probably we can think of. Then second is a rapid domestic acquisition, whether it is in a peace environment or it is a battlefield environment, and US continuously to procure these systems and equipments from the industries. In India, in fact, we have also started in emergency procurement, especially I think last few years back, because of the neighbors, what are they've been creating. And to face the war situation, I think they started this emergency procurement. Of course, maximum beneficiaries are PSUs because they already had equipments in place, so they have supplied. Private companies are not got benefit much about with this emergency procurement because they are in the phase of development of those systems and all, probably, but over a period of time, they may come out, with the technology or product, whatever they're looking for. But what I would like to mention here is some of the technology products, they must identify and they continue to procure in this particular model where the timelines can be minimized and they can have a continuity of the business. Then although the IDDM category has been highest priority, like, they have mentioned in our the recent last two defense procurement manual, but still there are some critical technology or product which we are still importing by virtue of, the delays in this particular thing. So which is, again, we need to make sure that we should not allow this. Then in US, there's a model called, there's a autonomous body called DARPA. This is a Defense Advanced Research Project Agency. is the autonomous body. They basically fund high risk and technologies for these startups. Actually, they play a lead role in building the ecosystem between startup and then MSME and industries with the government, so that they can have a tightly control over the technologies, and they'll make sure that they supply in time by coordinating with all the stakeholders. And in India, I think we can also see today DRDO is the only agency which can understand the technology of the defense and then also understand industry requirements, industry needs, industry expertise, and also they understand the startup or MSME. So the DRDO should play a major role here. I think what we suggest is DITI, that is DRDO Innovation and Transition Agency. Like DARPA, I think we have to start a DITI so that this agency can enable ecosystem in India with the startups, MSME, and the industry, so that it can work, coordinate with all of them, and also they can provide consultants, as one of our friend was mentioning here. And wherever it is possible, they can even handhold the companies to bring out the product in time. So these are the few suggestions what we have mentioned here. Then, of course, we have to strengthen the Tier 1, Tier 2 suppliers. Apart from the politically motive, corridors, I think better to bring out more corridors in the states based on the resources availability. I think recently there is a corridor has been inaugurated in Andhra for the drone manufacturing, because there are so many drone manufacturing guys that are around in Andhra, and based on that resources strength availability, they started up this. Today we have 2 corridors, I think, in one Tamil Nadu and Uttar Pradesh, but more corridors should come, cluster-based corridors, based on the resources. Like, for example, take Karnataka, Bangalore is known for IT and AI-based kind of a thing. Like in different states, different expertise available. Probably we have to look into this aspect. Then MSME, like as I mentioned, they want guaranteed orders for the products what they develop. I think some mechanism need to be worked out so that they can maintain that qualified manpower in those companies, and as well as they can maintain the technology so that for even after 5-10 years they can be in position to supply those products. Then shared testing and infrastructure is something which we need to look into that. That is also, of course, many speakers, they have mentioned about that. In Astra, actually, one thing I would like to mention that, we have created one facility, EMMC facility, about 15 years back. And we are the first to start this EMMC facility in a private company. But we understand the pain of getting those facilities, from any other agency. We have been offering to even our competitors. They come freely and they can make use of this facility, so that they should not get any their product should not be delayed for sake of this particular facility. Like that, all industries should be open, whatever the investment they can make it, but it should be freely available. And the DRDO should take initiation to certify those facilities so that they can make use of this. Then, so what are the other things like we can probably we can seek from the services is instead of making a blame game. So I think we have to ensure that early continuous user involvement in design and trials to prevent this requirement changes. This is something which we have to ask them. It is not only in the DRDO, but yeah, not only in DRDO, but even in the industries. The industries whosoever is taking up the development, critical development of critical technologies or products. In case if the end user is positioned there, or maybe can frequently if they can be part of the review committee and all, I think it helps them a lot to understand the end user's requirement well in advance. Then establish joint R&D boards among DRDO, academia, industry, and users. This is a part of DITI, whatever proposed. I think this also we can mention this. Then, this I don't want to again explain. There are many speakers talked about the T1 instead of L1. This is being there for so many years and all. We have been working out that and that. Although there is one system, the quality-based QC, BS and all, but it's not so effective. But I think we must bring out some model to see that at least for the critical projects, mission mode projects, we have to evolve T1 selection model. Then create incentives for OEMs to set up R&D centers in India. I think probably the tax holidays and can be given to those industries who wanted to set up R&D, critical R&D centers to take care of the future technologies. So this is all what I wanted to say about this particular segment. Thank you very much, and I am happy to take questions.
Thank you. The QAs, as I told earlier, all of you, we have a Google form. Please upload it there and we'll all address it in the roundtable. I request Sri Muralidharan to summarize his points, and I will summarize the session and then...
So 1 minute before we summarize, I would request the chair and co-chair to felicitate our speaker.
So thank you, audience, for a patient hearing of the 5 speakers, the chair and the co-chair. So one question that came up is, who will fund the private industry R&D, right? With a TDF, IDEX, too small. Probably the government heard that, and this year end, maybe end of 2025, early 2026, they are starting a 1 lakh crore deep tech R&D fund. Right? You can Google and check. There is supporting the only private industries, because government setups have been already given a lot of R&D funding. So this is only for private industries, deep R&D tech fund. This will be open to defense, space, biotech, any deep tech technology. But they are specifically mentioned about semiconductors, biotechnology, defense, and space. So this is one thing that's good news for the private industry. And the second issue was about, a lot of people talked about TOT. Okay, so as I said in the beginning, the private industry is evolving, and we may need not manufacturing TOT, but a real technology transfer, and we'll have to be part of. We should be ready. The industry should be ready for that, and we are getting ready. So soon we'll be partners, and we'll be designing MOSO systems, system engineering, and DRDO and academia will focus on the science conversion to technology. Then the other major challenges was specs keep changing. This is throughout the world, specs keep changing. So we can keep crying about it, but it won't, it will not go away. So how do we resolve that? So we need to bring in new technology to solve the change. Okay? So what I was telling one of my customers is, I'll give you an AI program and I'll give you a system. You speak into it and it'll give you the output. Okay? The AI system will design, build, and give you an output system in 2 hours. How does it sound? So it's very good. So then you won't know what to ask for it. Right? If you keep changing things, you don't know even what to ask for it. Right? So there are a lot of challenges. So the world over, things are going. Mr. Vinod from Centum talked about change over to software-defined systems. So can we have stock hardware and all functionalities are implemented in software, right? So if you have the stock hardware modular, and then we don't have to worry about major changes. The changes will come, but nobody knows what they want tomorrow. So the other point was, if I'm not given a roadmap, how do I plan my industry? Okay. Again, I'm talking about futuristic. Nobody will be able to give you a plan. Okay. Everybody asks me a plan, and nobody gives me inputs. So how do I create a plan? So we should know how can we manufacture things not in the regular assembly line method, but bespoke using 3D printing. Okay, today morning I make dosa, tomorrow morning I make idli, uttapa, everything is the same ingredient, same machine. So maybe we'll have to think out of the box or without a box, how to do these things better. Dr. Das has talked about celebrating synergy, innovation, and collaboration, but I'll request him to add celebrating failures also. Okay, many a times or most times we fail. Right? So how do we celebrate failures and understand why we failed and not repeat a failure, fail in a new area, right? So that should be one of our objectives. So we should encourage failures. Otherwise, there's no risk. See, all of the today's procurement says exactly I should do this. If I don't do this, they charge LD on us, right? So every time we have to go and tell them, justify why we could not do it in time. Forget about failures. Failures gone. So we should, as a country, understand and celebrate failures and learn from the failures and not repeat. We talked about semiconductors challenges. 65% of the semiconductors come from Taiwan. Even the US have to import from Taiwan. Designed by the US, but they have to import from Taiwan. For example, NVIDIA, Apple, Qualcomm, all of them import or rather get their chips fabricated in Taiwan. 65% of the high technology chips go from Taiwan to the US or anywhere else. Designed by them, partly designed by India. India contributes to a lot of semiconductor design. Most of the detailed design is done in India. The system design is done by the US and European companies, or mostly US companies, manufactured in Taiwan. So semiconductors is going to be a big issue. What fabs we are going to put in is only 28 nanometers. Okay, 28 nanometers may not do all that we need, but we should be able to take a good step. And so another thing is we need to design our chips. So we'll get a fab, but do we have a design? Yes, today we saw companies are working on Indian designs. So we should have our own. So the long term is we have our own chips, stock chips we make, use software to define functionality, use 3D printing to do these things. So we should be very innovative in thinking forward. Okay, we have a lot of problems, we'll solve all of them. And the DAP is only 15 years old. The new DAP is coming. So anything that we need to add to the DAP 2025, we should talk to SIDM and do that. So all of these things are tactical, but we also should think futuristic strategy. And Dr. Reddy talked about the agile development. Yes, that's one thing I urge the user to help us with. Don't get all the 100 features in one system. Get the critical things shortly, in a short time. So we also get some money. We deliver the item. We also feel good. And then they increase the things. With software different defined systems, this is really possible. With this, thank you all for your kind patience.
Thank you so much. Let me add a few points to summarize the whole thing in this session. One big thing has come out that India is moving from a capability to a leadership decade. This has been aptly brought out, and I think in this decade, whatever capability we build, we must go to the leadership at the next level. This has been brought out as a common denominator by everybody. Now, if you have to do so, one of the common things which has come out is instead of going for a project-driven model or a tender-driven model or a contract-driven model, we have to go to a platform-driven model. So I just wanted to inform the industry, yes, we are moving towards this direction. In fact, the way we migrate from a technology development project to a mission mode project, we are not going to change our vendor base any longer now. Earlier, it used to be that even if there is a small delta change, we used to go for a fresh open tender for various reasons. But now there are procurement clauses in place where if you can justify the cost for that delta increment or something, we will support you to enhance the capability of that product. You will have visibility of your order books more often than not. So this is one thing I wanted to convey. Yes, there are certain concerns with respect to the TOT. We will take it back. How to make the TOT more comprehensive. The source codes are not there today as a policy. We are trying to see how to incorporate that also into our policy framework. The spiral development model is very much a very critical element. We will take that forward. The trials and the induction process, unfortunately, it is a long-drawn process, and we can't see in the near future any escape route because of our varying climates and the extremes where we operate. We have a summer trial, we have a winter trial, we have a high-altitude trial, all kinds of trials. Also, what I'm seeing with the depleted strength, particularly with airborne platforms, of what we have today. Getting access to airborne platform for testing may not be a very frequent affair. So the digital twins is the way to go forward. Jointly as industry and DRDO, we need to synergize this effort to place more and more focus on the digital twin concept. Consultancy from DRDO again has been brought out today. Somebody pointed out about the COCO model. Yes, we are opening up many of the contracts, even though a formal model is not there in DRDO. We are inviting people to come to our premises and work, because every day if we cross each other's path, we understand each other much better. So that is one area also I'm focusing on. And finally, what has been brought out is the component base. Yes, it's a real challenge for us. So designers in DRDO, we take back this message that when we take up the design should be more for manufacturing, addressing obsolescence management, much faster, and replacement that is not depending on one particular partner, because as somebody pointed out rightly that today we are in a situation where we have no permanent friends. With that, I'll summarize this session. It has been a very illuminating experience with the industry, and let me thank our DG ECS for giving us an opportunity to open this up. Thank you so much.
Sir, I request DG ECS sir to facilitate the chair and co-chairs. Yes. Before we break for a high tea, I just have a small announcement. In the afternoon valedictory program, we have almost 20 awards being distributed for the industry partners. So I want all the industry partners, please make note of it. There are different kinds of awards that will be disclosed during the valedictory function. So I want all the industry partner participants to be present in the hall, definitely for the valedictory. And I request all of you to please assemble back within 15 minutes for the start of the next session.
EW environment and to have the ECCM adaptability for the whole. Advanced surveillance and coastal surveillance, because we need to also protect the coast as we get intrusions through them also. To network the complete system of sensors and then make it to an enhanced situational awareness for a quick reaction and a timely decision. Artificial intelligence and machine learning have to come in to do all sorts of back-end processing and do a mission support. And now with the recent Operation Sindoor, we also see now high mobility and rapid deployment is the order of the day to evade from what intelligence is being gathered by the enemy forces. So what at LRD for the next generation of technologies and radars, what you see on the top is all the technologies. What we see at the bottom is the systems, what these technologies are going to feed. For example, we need to make a radar with a swarm of UAVs. I'll talk about in detail about that in the later slides. We have MIMO radar, we have large array radars leading up to cognitive radar and quantum radars. As you can see from the left on the top, all the technologies we need to do for a stealth target detection, because enemy will sooner or later acquire some stealth targets and the next war will be on stealth. We need to also extend into the space domain, so the complete space object catalog has to be evolved, because we need to be strong in that domain also to prepare our ground operations, and at any point of time our space assets are always a threat even today. So all sorts of technologies are to be developed to feed into our next generation radars of LRD. Just to say a few radars what I mentioned in the previous slide, we need to go in for the cognitive radar and the quantum radar. Photonics, we are already on that. Quantum, we are just taken the baby step at the first. So we need to have high power GaN technology. We need to have very high power TR modules to be developed, because the war is not being fought nowadays by crossing the border. We have to fight it within the border. We have to fire our arms within the border. So for that, the aperture on the fighter aircraft or on the surveillance aircraft is going to be limited. It cannot be extended more. So with the available aperture, the only way to extend range is to have higher power that is to be transmitted to get the required power aperture. So highly efficient TR modules are required, because there is not going to be that much of electrical power or cooling power available on the aircraft. And with that, we need to also develop low power gallium arsenide or gallium nitride, MMICs, LTCCs. All these things are coming into picture now. Photonics, we are already developed a system with the photonics, radar system with the photonics technology incorporated into that. AI and other things what we have told earlier. Advanced materials, all the materials that are tunable to become metamaterials, that is also going to be occupying the future domain. Just to say a few of the technologies what I said in the previous slide, shared aperture antennas. As you can see on the ship, there are n number of antennas for n number of applications. To reduce the volume, size and weight and space, we need to have shared aperture and the technologies, challenges that are associated with that. Reconfigurable antennas, which will need a very good level of this technology in PCB, wherein we need to incorporate multiple antennas and switching mechanisms for the same. Frequency selective radomes, which is going to be also very challenging, wherein we will have to incorporate metal also to be engraved into the radome. So that is also a big challenge coming up now. Bistatic and multistatic radar technologies. We have already established a multistatic technology now. So now we have to go in for distributed netted arrays and swarm of arrays. So this is going to be the next level of radar, which is going to be used for next generation warfare. As you can see, I'll go to the next slide to show you the antenna array using UAVs as antenna elements. Every element of the radar will be mounted on a UAV. It will form an array and it can be launched from that ground, and it can aid the airborne fighter much ahead of him. It can go form an array in the forward area, detect the targets and give it as an advance information to the fighter pilot. So this can be a target, and the challenge what is going to be here is the positioning error, what you are going to achieve with the drones which are flying, with the wind conditions and the time synchronization between the elements. So these are the challenges that we expect to have in
such type of UAV clusters. We already started this job, and it's a big challenge that is being in front of us now. AI, ML in radars and multi-band and multi-static photonic radars. So here the challenge is to develop miniaturized where multiple channels, RF, data, video, everything over fiber is already being done by the industry. So all of them will be useful for this type of challenges what we are facing today. Next, we have quantum radar, cognitive radars. Work is already on that, and integrated sensing and communication. As you can see, here we have the challenge that is coming to quantum radar is on cryogenic cooling and the cost of implementation of the same, and difficulty in presenting or preserving the photon and development of high sensitivity detectors. Plus, the Rydberg quantum radar is also being done as of now. For the drone, now we want to integrate the drone radar with the next generation killer systems. For example, if you want to use it on a mobile platform, in a man-portable platform, the entire drone radar along with the killing mechanism has to be mounted on the soldier. So for that, we need miniaturized systems, anti-drone systems, and we also need to guide the drones to go against the swarm of drones to kill them. Then I said about the networking of the radars. So networking, if you can see, there is an Army network, Air Force network, and the Indian Navy network. So all these radars have to be networked. And then the entire operations of the complete radar system which are on the field will be brought to a centralized location. And the complete health of the radars will be at a centralized place. So the monitoring of the radar's health and the advisory from the central point can be told to replace which LRU is faulty in which radar. If the entire thing is networked like this, then to have a complete war scenario that can be played out, you can simulate targets. As you can see, the two red ones are simulated targets, and live targets are also on the air. The entire set of radars will detect. There will be ECM around, there will be EW, there will be SDR. Everything will be simulated to have a simulated target with our own real target defense mechanisms against that. So this is the list of all what I have told till now. In each set of radar subsystems, what are all the challenges? Just to highlight a few. The radar power systems are going to go from, and cooling systems are also going to be the same way. And vapor cooling is going to be another requirement now for the airborne systems. Then mechanicals, a large hundreds of tons of antenna is going to be mounted on a dual axis gimbal. So that is also going to be the next challenge which is going to happen in the radar mechanicals. Other than that, the rest of the things I have already covered in the previous things. Last, digital processing hardware. Today we are all importing processing boards from abroad. Now at any point of time these things can be stopped. So we need to have completely indigenous boards, qualify them, and the lifetime support for the software, firmware, and the BSP for all these boards. So this is also a so as you all